Okay. Yeah, we'll do FRQ practice tomorrow. What? Okay. Well, then I might have you take them home. Circle what thing? Because I wrote number 2 on everybody so that I would remember that this was number 2 whenever I went back to add the FRQ and the multiple choice together. 2 and 2. I know you did. That's why I circled it. Everybody else I wrote number 2. And I went to write number 2 and it was right there. Okay, number 2. I didn't. You might have been one of the first ones I did. Write number 2 on it up there where it says quiz. So we have the integral of 1 over 3x plus 12 dx. So as Noah said, this screams natural log to me. I did take out a 3 from the bottom first before I started. So that would be, if I took 3 out of here, that gives me 1 over 3 times x plus 4. And the reason I did this, I went through and did it first without taking the 3, and I noticed the way the answers are written, and this is one of the things I want y'all to start thinking about as you go through. If I'd done u substitution and let u be 3x plus 12, I'd have the natural log. I'd have that 1/3 there, right? But I'd have the natural log of 3x plus 12, and that's nowhere on there is written like that. So what I did was I said, well, how can I get it to look like the answer's there, knowing this is probably going to be a natural log type problem? And so if I took that 3 out, then I end up with 1/3 times the integral. Remember, you can pull that constant out like that. 1 over x plus 4. And then, of course, u would be x plus 4. If you even need to do the u substitution here, most of you can probably see that without doing it at this point. So the integral of 1 over u is, of course, the natural log of the absolute value of u plus c, and u is x plus 4, so it was b. Yeah. Flip over to, everybody good on 3? No? Okay, let's run through it real quick. 3 was C. 2 is B, and 3 is C. You want me just to run through the correct answer so you can write it beside the ones you missed so you know what they are? Okay. All right, I'm going to go through 1 through 10 first. C, B, C. 4 is B, A, B. 7 is D, A, D. And then 10 is A. $11, A, D, D. 14, B, C, A. 17, A, B, C. Okay.
14 was B, right?
14 was B.
Right. 17 was what?
17 was A. 16 was A. They marked it wrong. I'll check the key and make sure. Remind me as soon as I finish. 18 is D. 19 is C. 20 is C. 21 is A. 22 is B. 23 is A. 24 is C. 25 is D. 26 is C. 27 is C. 28 is B. 29 is A. And 30 is B. 76 is D. 77 is B. 78 is C. 79 is B. 80 is A. 81 is D. D, yeah. 82 is D. 83 is C. 84 is D. 85 is B. 86 is C. 87 is B. 88 is C. 89 is A. And 90 is C. Bless you. This, in y'all's defense, I felt like this was a hard test. Allison, which number was it? All right, Allison. Oh, it did mark 16 wrong for you. Okay. Put give you one more on up top. All right. All right, so for the quotient rule for number 3. So we have f of x equals 5 minus x over x cubed plus 2, and all it asked us to find was the derivative of x. So derivative of the top times the bottom minus the top times derivative of the bottom, all over the bottom squared. Take a look at the way the answers are written before you do more work than you have to do. The bottom, all the bottoms are exactly the same, so I don't even have to worry about that. They're all x cubed plus 2 squared. Okay, so we're just looking at the top, but I do need to expand it out because those are all written in standard form. So, negative x cubed minus 2 minus, and I'm going to keep this in parentheses for just a minute so you see, 15x squared minus 3x cubed. I'm not even going to worry about the bottom now. Remember, anything you can do to save time, they're not looking at your work. That work is for you. Don't write anything you don't have to, okay? So you got time to go back and really focus on what you need to focus on. All right, so negative x cubed minus 2 minus 15x squared plus 3x cubed. That gives me 2x cubed minus 15x squared minus 2 for the top. Does that make sense? I may have even looked at that in the beginning. I didn't, but just a little technique if you are struggling with time issues and gone, hey, look, all the bottoms are the same. I'm not even going to worry about that. Let me just worry about the top to start with. Okay. Questions about 4 or 5? Number 4. Oh, trap rule. Okay, well, let's go because y'all are struggling with this a lot. So this one is a non-calculator, and with the numbers that you got, the error would probably come in trying to do this without it, for me anyway. Trapezoidal sum, remember, is 1/2 height times base 1 plus base 2 for each trapezoid, and then add them together. Trapezoid 1, trapezoid 2, and trapezoid 3. There are 3 trapezoids there. It says number 4, trapezoidal sum with 3 subintervals from 0 to, and then it becomes just a computational thing. Everything's got a 1/2, so I just put that on the outside and know to multiply everything by that in the end. But the height varies, so I have to do the height each time. So from 0 to 1/2, that's a height of 1/2. Base 1 plus base 2. Plus, then the pink trapezoid here, 1/2 to 2 is how many? 1.5, or 3 over 2, and then 60 plus 40. Slow down? Okay. So this is asking us to find the trapezoidal sum with 3 subintervals. So I got the green trapezoid, the pink trapezoid, and the black trapezoid. Does that make sense? So the first one, for the green one, 0 to 1/2. Your x gives your height, even though that sounds kind of backwards. But this is the difference in your x. These are your y values of your 2 different trapezoids. I mean, of your 2 different ends there. So as opposed to the Riemann sum, where I just use either the left or the right end of the rectangle. Yeah. This is a distance of 1, this last one, and then of course 40 plus 30. And if you do all of these computations, you can't forget to divide it by 2, but you come up with 130. And remember, this is well, because it's 1/2 times, yeah. And just to show you what I did, I have to write, if you can do this in your head and you know 20 plus 60 is 80, and 1/2 of 80 is 40. However, remember, this is multiple choice, so you don't have to be so concerned with how much work you show. Do for me on your corrections, but not on. I just want you to work it out. I want to see you work it out. It's non-calculating. Divided by 2 is 50 times 3 is... I thought this was a lot without a calculator. It's not hard math, it's just a lot. 190, 260, and then 1/2 of 260 is, of course. Five was, of course, chain rule. Everybody put there is A. No. Derivative of, it asked me to find f prime of the square root of 2 pi. Well, first I have to find the derivative, and then it's going to replace the x. Why do you find the derivative? Because this is f prime. So first I'm going to find the derivative of this. So what's the derivative of sine? Cosine. But I can't forget that chain rule, right? So times 2x. Now to do f prime of the square root of 2 pi, this goes in for x here and here. Okay, so then what? Well, the square root of 2 pi squared just makes the square root go away, right? Times 2 square root of 2 pi. Now, if you look on your answers, even if you couldn't remember how to do something with this part, you know you're multiplying by 2 times the square root of 2 pi, I would go ahead and eliminate B and C if I just didn't even know how to go there, and I'd mark out. And that's a technique I use a lot. Mark out what you know won't work. Get it down to where you can at least get to a couple choices that, so your odds are better than 25%, right? You get down to 50-50 shot, you got a lot better chance of guessing right. But the cosine of 3 pi, so I've looped all the way around the unit circle, and then I go one more pi over. So I'm really at pi. That's the same thing as the cosine of pi, which is -1, and then times, of course, 2 times the square root of 2 pi. So 2 pi loops all the way around one time, right? And then you go another pi. Ooh, 7 was a good one. Yeah. 6, I'm assuming everybody's good. This is an A-rock problem. Find f of 1 and f of 5, and then do the slope between the two. 7, the reason 7 was tricky. Immediately before I even read the whole problem, whenever I looked at this, I came down below it and I wrote, okay, wait. And I knew that was going to have some play in the problem. Remember that rule? If you switch the bounds, you change the sign of the number. I noticed that the smaller number was on top, and so I knew anytime they do that, they're testing to see if you know that you can change the bounds, change the sign of the value. All right, so then it said from 4 to 6 is 5. So what is -10 to 6? Well, -10 to 6 would be, I could do -10 to 4, and then pick up from 4 to 6 and just add those two things together. So it's 8, which is D. Oh. Yes. Ooh, another good one. Number 8, if the function is given by f of x equals e to the x over 3, which of the following is an equation of the line tangent to the graph of the point? And they give you this point. It doesn't matter how nasty it looks, it's still a point nonetheless. And so this is my x and my y, which is nice because I'm not even going to have to plug in to find that y. Usually they'll say at x equals 3 log 4. If they didn't do that, they gave you the y also, so you didn't have to plug in. So all I'm going to need to do is find the derivative. So e to the x over 3, chain rule times 1/3, because I got to do the derivative of that exponent, right? So now what is the derivative? Because at 3 log 4, because that is going to be my slope of my tangent. And I'll have a point and a slope. Well, 1/3 times e to the 3 log 4 over 3. One-third. What is e to the log 4? 4. The e and the log cancel then. So what's the slope? 4/3. And if you look, they even left the equations of the lines in point slope form for you, which was nice. Even if you got, well, I guess you'd need. You could have automatically eliminated D because they didn't use the X and the Y in the four. And so if you didn't even know how to do it, you recognize point slope form. Get you down to at least a 33.33% chance of guessing right. It's a game, y'all. You got to eliminate what, if you don't know how to work it, eliminate what you can. I know. Okay, so never leave them blank. Always, when you're there, okay, this is important because 9 times out of 10, you're not going to have time to come back. You know what I'm saying? And depending on where it is, always, 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 when you're there, eliminate what you can. If it's a guess, bubble it, but star it so you know to come back to it. Yeah, that's a problem. Yeah, did you say 9 though? Yeah. There's really not any work to show here, but this is 2 and this is 0 and this is 3. And it was just a straightforward graph. It just wanted this was an integral. The relationship between from 0 to 2, which is positive, from 2 to 3, which is negative, and then when you add them together, where does it stand? Well, this is obviously the biggest value. The next biggest value is when you add them together, so the whole thing, right? Or did it say add them together? Am I confused? 0 to 3 is the total, yeah. So so it would go from 0 to 2, and then it would go from 0 to 3, and then it would go from 2 to 3 because that's the lowest. But you got to look at the way the alligator mouth is, right? So you would have to start with the smallest one. Yeah. It's D. Because then it's the whole thing. Because when you add the positive and the negative area. Zero to 2 is bigger than from 0 to 3. That's why the alligator mouth is eating the 0 to 2. It's the bigger. Listen, they get confusing for me. I have to think about the alligator eats the most. area is always positive if they ask you to find an area, but this is asking you for the integral. Integral can be negative. You said number 10? Y'all are going to be left with a lot to work on your own. Yeah. So this was an antiderivative. This was a u sub of a definite integral. So I let u be, remember when you see these different degrees here, and you see one is less than the other, it's probably going to be a u sub. Let u be x cubed plus 1. That means du is 3x squared dx. You've got x squared dx. I need a 3 here, but to counter that, I'd have to put a 1/3 here. So if u is x cubed plus 1, du is 3x squared. So this is u to the 1/2. I have x squared, but I don't have the 3 in front of it. So in order to make that a 3, I'd have to counter it with a 1/3. So I've got u to the 1/2, but I also have to adjust my bounds because I do have a u in there. So u of 0 would be 1, and u of 2, 2 to the 3rd is 8, plus 1 is 9. And now it's an antiderivative, and it becomes a much easier problem. 2/3 u to the 3 over 2 from 1 to 9. Well, so that's the square root of 9 cubed.
I thought you have to keep that 1/3. 1/3 that you pulled out. I thought you had to keep it.
Oh, yeah, you did. I'm sorry. I forgot my 1/3 that I put on there. I'm trying to rush through the problem. So if you don't remember rational exponents, again, algebra comes back to bite you in the butt. 3 over 2, that's the second root of 9 raised to the 3rd power. Remember the sunshine? I don't remember the sunshine about who gets burnt. So he's out in the sun here, so when you change forms, he's under here in the shade. He's in the shade here, so when you change forms, he gets a suntan. Here's your sun shining down on everybody. They take turns on who gets in the sun. All right, so the square root of 9 is 3. 3 cubed is 27, minus 1 to 3 halves is obviously just 1. So you got 2/9 times 26. 52 over 9. 52 over 9, which is A. Yes. I messed up on 11. Y'all got 11? That's implicit differentiation, so make sure you separate your variables there. I'll set up 11 for you and let you go back and solve it just to show you real quick. If you have x squared plus xy minus 3y equals 3, and it says at the point 2, 1, find dy dx, this is what I'm going to do first, and then I'm going to plug this value in for x and for y. So derivative with respect to x, 2x plus product rule, derivative of the first times the second plus the first. What's the derivative of y with respect to x? derivative of negative 3y with respect to x is negative 3 dy dx equals 0. It's 11, yeah. Now you should have enough that you can go back and solve that for dy dx and plug your value in. But make sure when you have x's and y's and it asks you to find dy dx, you are deriving with respect to x. So every time you take the derivative of a variable that is not x, you follow it with d variable over dx. Yes. Mm-hmm. Move these two over here, factor out the dy dx, divide by x minus 3, and then you'll plug in for x and y. Remember, I'll answer your questions on Thursday too after you've had some time to go through and work through. Everybody got 12? 12s for the rate, so all you did was find the derivative and plug in 3 there. 13, is that the one you were saying? All right, so let me tell you my reasoning for 13, because this is one of those techniques that I used for this one. It took me a little while for this one too, because my first gut instinct was I have no idea because I don't know what these graphs look like in A through D. So I have a couple of options. I could plug in a couple of points that I see on here, like maybe 2, 0 and 0, 4, and see which one gives me what. But that's going to be a lot of work. So let me reason through what I know, because I see some patterns in this graph. The first thing I see is every time x is 0, the slope is 0. Right? Do you see that? And every time x is 4, the slope is 0. And I meant y. I'm sorry. I even wrote it on here. Slope is 0 when y equals 4 and y equals 0. Right? Are y'all okay there? So then I looked at the equations, and the first thing I did was I marked out a, because I said that's 0 when x is 0. Right? That would work, because when y is 4, that would work. But when x is 0, well, every single time x is 0, that would give me a 0 slope there, right? So I should have on my y-axis a 0 slope if that's the case, so that doesn't work. Well, then I thought C follows that same pattern, right? Because you multiply by 0, everything from 0. So that automatically knocked out A and C for me to start with. So right there, just looking at that, I'm down to a 50-50 shot with this one. Okay, so 2 equations are better to work with than 1. But both of those work with 0 when y is 0 and y is 4. There are no x's in there, right? X doesn't even go into play. I did look at that y squared and thought, okay, what does that tell me? That tells me that that y is always positive. Do you agree? No matter what I plug in for that y, it's going to be positive. So as long as what's in parentheses is positive, my slope's going to be positive. You agree with that? So what could I plug in between 4, if it's 4 minus y, when is that positive? Greater than 4, right? So I looked on the graph and I'm thinking, when y is bigger than 4, is my slope less than 4, right, less than 4. So every time y is less than 4, is my slope positive? Yes. If you look on that graph, anywhere below, it's always positive. And so that's why I chose B. I saw that B, and if you don't understand that reasoning, pick a point. Pick a point and plug into those 2 equations and see which one works. You're only dealing with y's there, not with x's. And you'll find it's D. Okay. But again, that would be one. I would eliminate A and C. I would take a shot in the dark, bubble it in, start, and come back and start plugging in points if I had time. If it was me. That would be my thought process. Depending on how time is going, look at what time it is. Look at how much time you have left. You're on 13. Okay. Yeah. There you go. But then you're at a 50-50 shot again, and who knows? You might choose the right. Oh, it was wrong. Okay, well.
Where did you get 5 from?
What? 5 on 14? What 5 are you talking? You talking about the t over 5?
Yeah. Is that which one is up on bottom?
Okay, so look, it tells you that dy dt equals ky. Okay, this is where we said these are nothing more than PERT problems when you see these. And when I saw, look at the way the answers are written, and I'm thinking PERT. Okay, I see E in every single one of them, and I'm talking about. So I need to find this. So it told me, actually, yeah, I need to find K. It told me that at time t equals 0, the weight of the yeast population is 120 grams and is increasing at the rate of 24 grams per day, right? And I started with, say, the rate is 120, so that is my dy dt, because that's a rate, equals 24 times k. No, is it decreasing? Increasing. What did I do here? I have 24 equals 120k. Oh, yeah, dy dt is 24. I did it, yeah. The rate is 24, because this is grams per day, 120k. This is initial, what you start with. This is your k that you found, your rate that is increasing or decreasing, and t is your time, which stays in there. So if you look, I started with how many? 120. 120 e. We found the rate to be, well, it looks like they've simplified this. So 24, I literally just started dividing by 2 because I could not think of this in my head. And I was, okay, so I went 12 over 60. I went 6 over 30, which is 1 over 5. Right. This is a fraction with the denominator greater than the numerator. It's got to be right. Right, but that's where the 5 came from. That's where the 1/5. Looking at my pretty sign chart, y'all. Okay. 15. Which of the following statements is false? Okay, so I did the same, and I went through. I thought this one. I think this is one of the ones I have highlighted. This is one of the ones I have highlighted. I got it right, but I wasn't sure how to explain to you well between C and D. Because here was my reasoning. I automatically eliminated A and B. Do we all see that A and B doesn't work there? Okay. All right. The limit as x approaches 1 of f of x. So look at f of x equals 0. It says which of the following statements is false? Well, that limit is because the left-hand limit and the right-hand limit come into the same value. The function value is not that, but the limit is that value. So I automatically eliminated A. Then B, it says the limit as x approaches 2 of g of x does not exist. Well, it doesn't exist because the left-hand limit and the right-hand limit. So that's a true statement. So I marked that one out. Remember, I'm looking for a false statement. For part C, what I looked at was I thought, okay, g of x plus 1 would move g to the left 1, right? And part D would move f to the left 1. Right? And so, right, isn't that what our function transformations do? If I've got f of x plus 1, that would move me to the left 1. So the first one I looked at for whatever reason was D, because it was a little easier for me to see on there that if I moved it to the left 1, the limit would still exist because the limit still existed at 1 on G. So no matter what I did, I'm still okay there to exist on both. So I eliminated D and knew that it had to be C from there. And because I also looked, if I move G to the left 1, I'm not sure what's going on there. I'm not sure what's going to happen. I've got a jump discontinuity. I don't know. So C was my one that I knew I could. I answered this one by elimination. I knew A, B, and D were true statements. I wasn't sure about C, but there wasn't another one to pick, so that's what I. Yes, it was a think through problem. Because even if I move F around, if I move it to the left, that limit always, there is not a point on F where the limit's not going to exist. On G, there's a jump, but it's at 2. Right.
So is that saying when you multiply f of x times x?
Yes. Yes.
So how can you multiply these two things?
That's what I say. You really have to be conceptual about this one. Yes, that's what I would do. That's the way I did it, yeah. That's not always true. I try to tell y'all my reasoning to hope that it helps you see that even sometimes I don't know. In a time situation, I don't know. And it's sometimes easier just to eliminate. But that was one of the ones I had highlighted. 20 was the other one. All right, 16 or 17, are y'all okay there? 16 or 17? 16 was very, very, very straightforward, but you had to understand this wanted you to do the they were very easy derivatives. The first derivative was 12x minus 3 times 2, 6x squared.
That's where you find your zero.
Yes. So we set them equal to 0, and we find
Hey,
I just tried to do anything I could to very easily identify the zeros here. So the zeros, and this is the way my sign chart looks. I lined them up on top of each other. This is going to be my first derivative. This is going to be my second derivative. So the first derivative equals 0 at 0 and 2. My second derivative is going to equal 0 at 1, which happens to fall in the middle of those two intervals. And it asks me concave up and increasing, so I'm going to have to look at these things together. Okay. If you plug in, you should find negative, positive, negative, which is increasing the, oops. And then for the second derivative, you should find positive and negative. Of course, go back and work this on yours so you see. But it asks for the interval of concave up and increasing. Here's concave up, and the only place it's increasing for that is this interval. So from 0 to 1. It took a little longer. It'll take you a little longer when you do your corrections because you'll have to, find those points and stuff. That one took a little bit because you had to compare it to both. But of course, you know me, I like my sign charts for everything. 17 was particle motion. What's the first time so it gives you position, it asks you for when velocity is 0. So obviously we know that we're finding the derivative, right? So derivative of, we've got 12e to the negative t sine t. So I've got myself in a product rule situation. 12 times. Derivative of the first would be e to the negative t, but I got to chain rule it, times the second, plus the first, derivative of the second. What's the derivative of sine t? When does that piece equal 0? So this is going to be negative sine t, e to the negative t, plus e to the negative t plus sine t. I factored out an e to the negative t. I thought about the product rule, which says that two or more things multiplied together, thing one, thing two, equaling 0, one or both of them must be 0. This is never going to be 0 because you're never going to, there's nothing you can plug in for t that's going to make that 0. When you raise e to a value, it's never going to be 0. So I automatically eliminated that. Well, now I'm looking, when will that equal 0? When it equals each other. So where on the unit circle do they first equal each other? Pi over 4. Done. Does that make sense how we reason through that? Oh, if you missed 18, kick yourself. Yeah. I had a ton of work and then I went, wait, this is the stinking fundamental thing. It's literally asking you for the derivative of the integral. It's gone. It just changes that variable based on that top variable there. The bottom bound, the lower bound does not matter, so it's just d. It was a very, very straightforward fundamental theorem question. You just plug in X. Oh, word. I looked at that. I did not read through the question completely, and I went, okay, what's the antiderivative of tangent x secant x? I'm going to do a u substitution, and I started doing it, and I went, oh, I'm so dumb. It literally, I didn't even read, so I went back and circled it, so I made sure to tell y'all, don't make my mistake. Make sure you read the whole question completely before you try to answer. No. I would, if you miss that one, for your corrections, write fundamental theorem. That's what you do. Fundamental theorem. 19. Everybody get on 19? No. Yeah. 19 was tangent line. F of x equals. That's exactly right. So the derivative at the point gives us the slope. This one did not give us, it was not so nice as the last one where it gave us the point with the y value. So it says when x equals pi over 2, and then it says to use that to find f of 1.5. So you got to kind of decipher all this information on what it is it's giving us. So the first thing I'm going to do, and you better believe, or I guarantee I bet if you put 1.5 in here, that's one of the answers. Nope, that's not. All right, so first thing I'm going to do is derivative. So the derivative, remember we need a slope and a point because it asks us for a line. Sorry. Derivative of f would be negative 2 sine x. I felt like they were kind of nice on the unit circle values they gave you. They were all pi over 2s, pi over 4s, or even pi's. So now what is the derivative at pi over 2? Well, what is the sine of pi over 2? 1, because I'm up at the top of the unit circle, so I get negative 2. That's my slope. Now I need a point. What point am I going to use? I have to use x equals pi over 2, right? So I have to plug it in. That's why I said this one's got a little more work than the other. To cosine pi over 2 plus 1, what is the cosine of pi over 2? 0. So that point, now I have a slope, which is negative 2. I have a point, which is pi over 2, 1. And I'm just going to plug in point slope. Y minus 1 equals negative 2 times x minus pi over 2. That's still not the whole problem because they asked me to use that line to estimate f of 1.5. So you throw in 1.5, which is 3 over 2, right? Fractions are your friends on these kind of problems when you don't have a calculator because that's probably the way the answer is going to be. 2, 2, 2. But I got this negative out here. So I have negative 3 plus pi plus 1, which is negative 2 plus pi. Yay! I have to look up 20 to see how you're supposed to know that without a calculator. That's the other highlighted one I have. I had 2 highlighted that I needed to look up to explain to you, and 20 was the second one. 15, 20. So it is a jump discontinuity at x equals 2. We know that something's happening at 2. That's when my denominator is equaling 0, but it's not a vertical asymptote because it's not a rational function. I eliminated d from the start. I had that one marked out. So I had it down to 3, and without a calculator, I was not 100% sure how to answer that one. So I'm going to look up what you're exactly supposed to know about that one. I'm not sure. I'm not sure if that's what I really want to look up is x over the absolute value of x a parent function that you're supposed to know, that you should know? You see what I'm saying? Or is it because I want to make sure I tell you right? But I do have that one, and I will look it up, and I'll let you know. But we do know we can eliminate d because you don't have a rational function. There's not a polynomial in the bottom that equals 0 there. So it's not a vertical asymptote. So I eliminated d, but then from there I still had a, b, and c left. All right, 21 was a straight up alternate definition of the derivative. For what? For 20, you can just start or something, come back. We'll do that one together Thursday. Yeah, 21 was the straight up definition of a derivative at the point x equals 3. Did y'all recognize that? So there are 2 definitions of a derivative that we talked about. One was that difference quotient, and the other one was this one. The limit as x goes to 3 of f of x minus f of 3 over x minus 3. The other one dealt with the h, remember? The h went to 0. So this, all they wanted you to do was recognize that that was the definition of a derivative. The derivative of the log x is 1 over x, and then if you plug in 3, 1 over 3. Remember, when you're stumped, take a derivative. That's literally what you did here. The derivative of f of x was 1 over x. You probably plugged into there, which you could have done. If you recognize that being the alternate definition of a derivative, it was a 5-second question. But if you didn't, Allison said she plugged in the limit as x goes to 3. F of x was the log of x minus.
And then I did L'Hopital. And then I did L'Hopital 1 over x over 1. But it was just, I was just like, oh, I'll just put 1 over 3.
Gotcha. But this is so the definition of a derivative at this is the limit as x goes to 3. This equals this. And that's on one of those little colored sheets I gave you, the 2 definitions, formal definitions. There are so many questions that will test your knowledge of definitions.
Like, what are we supposed to do with that?
With what?
Like, what
you don't have to do anything with it. If you recognize that it's the derivative, and they give you, because they told you that f of x is log x, then I just said, oh, well, then what's f prime of 3? 1 over x, which is 1 over 3. That was a quickie. 22 was hard. Yes, 22?
Yeah.
It was hard. I don't know that it was so hard as it was very labor intensive. So, I mean, I spent a lot of time on 22. I have a lot of work. So, it was a DiffEQ. And remember, anytime you have a differential equation that you are asked to solve, you must first do what with the variables? Separate them. That's exactly right. I did a cross multiply kind of thing. So I had 2x plus 1 dy equals 2y dx. My variables are still not separated. I got to get them the other way. So this ended up being dy over 2y equals dx over 2x plus 1. It's hard for me to see that way, so I rewrote it this way. Again, I spent a long time because I have to be able to see it and make it make sense to me. Now, integrate. Not yet. We'll do that after we integrate. All right, so natural log situation, both sides. Yes. On this side, if u is 2y, what's du? 2. So I'm going to need a 1/2 here. Are y'all with me there? The integral here would be 1/2 the log of u, which is 2y. Yes. Again with the 1/2, the log with my plus c. I plugged in at this point, and it had, I don't know what I did. Okay, so that means 0e is a point. I need to use that to find my constant of integration. So I would definitely plug that in now. Okay. When you plug that in now, still don't have a calculator, right? I just have log of y on mine at this point. Where did the 2 go? Mm-mm. Oh, yes. I didn't do this because I didn't want to do a u substitution and get messy. I did that. Do you agree or disagree? Sorry, like that. So I pulled it out here so that I wouldn't have to worry about it here. Now the log of e, bless you, 2 times 0 plus 1. What's the log of e? 1. You got 1/2. Ren, I feel like you're fixing to stare all through my board. No, it's okay. Oh, did you? Okay. No, you were looking like, I didn't know if you were confused or you just, okay, 1/2. 2 plus 1 is, oh no, 0 plus 1, I'm sorry. Log of 1 is 0, that's gone. So what is c? C is 1/2. Still not done with this problem. All that gave, yes. So that goes back to this point. Remember, that was the whole point that I was trying to get to. So 1/2 log y equals 1/2 log 2x plus 1 plus 1/2. I said, well, everybody's got a 1/2, so I'm going to take a 1/2 from everybody. And I went, just divided by 1/2 everything. So now I've got log y equals log 2x plus 1 plus 1. I'm ready to do what? Yep, E everybody. Okay, because remember the goal is to solve for y. So now I have y equals. Now remember, adding exponents means that at some point I multiplied with the same base. So this is the same thing as e log 2x plus 1 times e to the first. Agree? So this is 2x plus 1 times e, which is now starting to look like some of the answers. If I distribute that e through, 2ex plus e, b. That was a lot. How did I get the y? Well, because this is the same thing as this. So these cancel and leave me the 2x plus 1, and then it's times e. Yes. 23 was another one while I'm there that I erased because I didn't read it adequately. It said perpendicular to the y-axis, not the x-axis. So I was with respect to y and not x. So that means you could have eliminated from the very beginning what? C and D, because that's not with respect to. And I guess theoretically you could have done it, but I would have eliminated that because knowing that this is a non-calculator and I'm going through.
It was in y.
Yep, you had to solve each equation for for x instead of y, and you had to do the area with respect to y. So it's right curve minus left curve.
Even if you did it with respect to x, the balance works for x.
Yeah, I was in the balance.
The 0 to 2 is right.
If it was with respect to x, it would be. Because the point of intersection was 2, 4. This one was hard because it said because your cross sections had to be perpendicular to the y-axis. So I would say you really couldn't do this one with respect to x. Because it's a cross section instead of just a volume.
24, why can't you plug in 12 for everywhere? Start by 8.
Because it says the average value is 12. So you have to remember average value is 1 over b minus a times the integral from a to b of f of x. So it says that the average value of a continuous function on -2 to 4 is 12. So that means that from -2 to 4 of f of x, 1 over 4 minus -2 equals 12. You had to solve it first for f of x, right? I think that's what I did. Oh no, so
Yeah, that's what I said.
this, I find that there's some years there are just themes that go throughout the test, and this is one of the ones where they're constantly wanting you to take things out of the integral and put them on the outside. So like this one is 1/8, the integral from -2 to 4 of f of x dx. So if I can use this to solve for this, you see what I'm saying? They give you, the average value of that function has absolutely nothing to do with what they're asking you. But why? The reason they're giving it to you is so that you know the definition of the average value of a function, and you set it equal to 12. Well, when I do that, this is 1 over 6 times negative 2 to 4 f of x equals 12, right? If I get rid of that 1/6 by multiplying both sides of the equation by 6, then I find out, well, guess what? This integral is 72. They asked me to find this. I could just pull 1/8 out.
Every single value we talked about is on here for now.
Yes.
Wait, so divide 72 by 8.
Yeah.
Yes.
So that's it?
Yes. So this is 1/8 times, and this is 72.
It makes sense. Like,
The same thing happened with that 77. They took the fundamental theorem, gave you a couple little pieces of it, and then you had to solve the equation to find the missing piece. That's the same thing they did here. Yes. It was 24.
That antiderivative. That's still not the right answer. I don't know what.
I don't know how that works, Katie. Yeah. We'll finish them on Thursday. 26. Oh, 26. I did L'Hopital 3 times. See? It's D. Hold on, I'll do 25. Let me do 26 since I already started, and then I'll do 25. If you plug in, or if you think about infinity going in here, what did I do here? I did 1 over.
Do whatever e 3x times plus x times 3.
Yeah, why did I do that?
Why'd you do that?
Yeah.
I don't know. I did it.
Oh. If you think about infinity going in here, I would have the log of infinity divided by infinity, which is going to be like infinity over infinity. I L'Hopitaled it to start with. So the derivative up here would be 1 over, because the derivative of a natural log, 1 over e to the 3x plus x times, and then I did chain rule. So e to the 3x, and then I did chain rule again. All over the derivative of the bottom, right? So I cleaned it up a little bit, which means these two are in the top. So I've got 3e to the 3x over e to the 3x plus x. And I'm still going to infinity. Again, I'm in a situation of an infinity over infinity kind of deal. So I did another derivative. Yep. 3e to the 3x times 3 over e to the 3x times 3 plus 1. 9e to the 3x over 3e to the 3x plus 1. That plus 1 is not going to impact me much at all. Do you agree? That little plus 1, what is it going to do? So I thought, okay, that's not going to impact me. These are the same. 9 divided by 3 is 3. Because when you're talking about infinities, what is 1 going to do in the denominator if you add it to? It's infinity plus 1. You are right, infinity plus 1. Let me talk about 25 real quick. The figure above shows the graphs of the function f and g. If h of x equals f of x times g of x, then the derivative of h at 2. So the first thing I did, well, if h of x, some of these, y'all, I feel like when you look at them, you go, oh my gosh, that's all I had to do. Well, how do I'm asked to find this. So to find that, I first need to find this. Well, that's nothing but product rule all day long. Derivative of the first times the second plus the first, 25, times derivative of the second. See? I know these are linear functions, so the derivative of each one of them is a constant, and it's just the slope of that line. So the slope of f is 1/2, and I literally looked on there and counted rise over run. So no matter where I am, this is a half. The slope of g is -2. So now to find h prime of 2, all I need to do is find g of 2 and f of 2. Well, those are points on the graph. G of 2 is 1. F of 2 is 3. And if you add those together, you'll get a -11 over 2. Dang it, we almost got through it. That's okay. Put them in your folder. Let me get them. We'll finish it. We'll work on it Thursday.